Good, bad, no? Complete the truth table. So this is going back to a question like yesterday. Now, first of all, number 5. Now, you don't have to do all I've done here now. I have traced through it all to show you everything here. But basically, you've got 2 inputs. So, because you've got 2 inputs, 0, 0, 0, 1, 1, 0, 1, 1. Right, they're going to be all your inputs again. That is going to happen. Like you could have a 0 on A and a 0 on B. A 0 going in at A, a 1 going in at B, a 1 going in at A. It's a bit like probability. All the possible inputs that you can have going in there. So, going back to our circuit here. What you've got then, now you need to be awful careful here. Because A coming in here, what does that split up into? It splits up into 2 A's. A, as you said there, Luke, A and A. Now that's only going to get me as far as there. I've still got to go and reverse it then to get me a not and. So, I just went from left to right. I did A and A first. So, if A is 0, that's going to be 0 and 0, giving me 0. If A is 0, that's going to be 0 and 0, giving me 0. If B is 1, that's going to give me, if A is 1, that's going to be A and A, which is 1 and 1. So, that's like looking here. Right, we've 0 coming in. It's going to split up into a 0 and a 0. If we have a 1 coming in, it's going to split up into a 1 and a 1. Do you know? So it breaks up into 2 there, but it's a bit unusual, so just watch out for it. You had to do exactly the same thing with B. 0 coming in, well it split up into 2 then, 2 inputs of 0 and 0, even though B was only a single input. But basically, B and B, they're giving you that. And so B and B, 0 and 0 is 0. 1 and 1 is 1 and gate, if both inputs are true. 0 and 0 is 0, and 1 and 1 gives you 1. Right, then you had to go and reverse them. So, whatever answer you got here, for A and A, you had to get the not A and A. And you had to get the not B and B. So, A and A, when we reverse that to not A and A, so that's 0, becomes a 1. That's 0, becomes a 1. That's 1, becomes a 0. And that's 1, and becomes a 0. And the same thing down below. We have B and B. We need to get not B and B. So it brings us up to that point. And not B and B will give us 1, 0, 1, 0. So, and I have that written down the next time I couldn't fit it. 1, 0, 1, 0. And on my diagram, so did I have a diagram down here at all? I don't think I did. But I call that for myself. I called it, at this stage, must have been OR. So I had Q, and then I had P here, and then I had OR here. So just to make it a bit easier, look at it. Well, the answer I got up here, I called it P. The answer down here, I called it OR. And you see what you've got to go and do for the next bit then, is forgetting that not bit here, you have to go P and OR now to get this. And so P and OR, both inputs must be true. So you've got 2 1s here. So if I've got any 1s on the top, I'm laughing. And I've got 1 1 on top here, so I'll get an output of 1. Otherwise we get 0 for the rest. And then you've got to go and reverse that at the end, because you've got the not and that will become input 1, output 0, and the rest of them output 1. What does that look like? What does it look like? What gate? A what? No. An OR gate. It's an OR gate. If either input is true. So just think to yourself, if you had an A and a B here, 0, 0, 0, 1, 1, 0, 1, 1, if either input is true, or if both inputs are true, you get an output of 1. So that circuit asks you to identify what it represents. It represents an OR gate. It represents an OR gate. So as I think I've wrote that down below here, it represents an OR gate there.